So I want to explain you two things about the program. The first one is that we always need the software to be online. This one, Aurora. So usually what we recommend is just to go to recent projects and to open the last project which was there. And since then everything is already being connected. Like the Ethernet is good, everything is turned on. So now we are ready to go. Basically what we just need to do is to go to runtime, and that's it. So basically the whole purpose of this is we have several industrial protocols. As you might have seen here, some of the machines you have there, they are connected through a serial port, which is normally a Modbus connection. This one is connecting through Ethernet, Modbus. This is the technology that is connecting this card to here. So this is the Ethernet. So what is this machine precisely? So we have the different instruments in here, and they are sending signals to the board, and then to the board we are sending them to the this is a network. This is a network card. So in here we have 4 different modules. This is the input this is the energy module. So in here is where you connect it to the electricity. This is the input module, and this one, and these ones are for outputs, and there's one for analogical inputs and analogical outputs. So this is basically just gathering information and is sending information to the program, so that the program is sending it to the cloud. So what's missing in here to do a normal process? So what's missing here is a PLC. I've seen in the other room that you have PLCs from Festo, which are like the brain. They are programmed so that whenever there's a signal that goes to the PLC that says, right now the sensor is too high, the water sensor is high, then the PLC, the signal goes to the PLC. PLC decides what to do. Oh, when this happens, we have to do this, and it sends a feedback to the system. So either it shuts down the motor or it closes a valve or whatever. So it's a loop, which means system, card, the brain thinks, and then it sends feedback. So this is normally how it works. Now, since this system does not have a PLC or a brain, because normally the provider the original provider from this machine, they had their own brain in the computer. But now, since we wanted to move it to the cloud, we have a brain in the cloud that is analyzing everything and is going to do it. So the other part of the solution is Yaga, which is the cloud. So the way your portal is going to be similar. This is like for because I'm the super admin, but for yours as a teacher will be very mostly the same. Now what we have in here is the brain, which is the ladder logic. So normally, how do you program a PLC is with the ladder logic, which is this one. We have different programs that decide exactly what to do and what not to do. So I'm going to open here the chemical station, which is this specific training. So this is a ladder logic program to control things. All right. So I'm going to take the time just to explain you right now how is the logic. It's very simple. So the logic is, have you ever worked with electrical circuits?
It's a contact plan.
It's a contact plan, exactly. Exactly, this is a contact plan. This is why ladder logic is more than 90% of industrial solution is this one, is ladder logic, because it's contact plan. So what we need to know in here is that we have this variable table in here, and we have all the different tags linked here. This program, you can use it like it is. What I'm telling you, I'm just explaining you for the sake of explaining you, because normally it just works. I just have to do a click and it can connect automatically. You don't have to do anything. But I'm explaining you how it is meant to be. So we have this program. We can switch between the names of here or the ladder logic name. So the ladder logic name, for instance, here P1, which is this one. This is actually equivalent to pressing the button in here to start one of these buttons.
It's the left one.
Yes. So there is one condition for safety that I apply in here, which is the system cannot start. The system cannot start unless there is water on the system. You're gonna go here to this launch VR mode, and it's gonna open the 3D experience. So this is how it's expected for the students to use it. It's just that simple. You connect here, and then everyone who's connected to the experience at the same time can be able to modify it. Just gonna reduce the sound here for. So this is what's gonna happen when they click on this this button. This is the web version of the experience, which means that even you have a mobile phone, or you have your desktop or tablet, you can see exactly the same thing. But this is meant to be used with the VR headset. So normally, in the VR headset, you go to medusadigital.com, you go into the browser, and then you do exactly the same as I did. The only difference is that in the browser with the VR headset, it's going to have a VR button in here. You click it, and then you'll be in immersive mode, and you'll be like everything, you'll see everything like in 3D. So this is like the learning environment. This learning environment has several things which are very important to notice. So the first one is that it's multi-language. Right now, this is the American language. Normally in VR, I'm going to open the VR so someone can follow the experience as well. So you're going to see that all the menus are in the controller, so it's more easy. It's more intuitive. What is important to tell is that here the instructions for the students are there. So we saw that the ladder logic for the heating system is rung number 1, heating cycle, start pump M4. Only possible if sensor B3 is on, meaning there's water in T1. So since there is water, we know it because it's in here. Mm-hmm. Now we can start from here. We already did it with the VR. Now we do it with this. I can also stop the entire system, like in here, or I can do it with this button in here. It's the same. Mm-hmm. I'm gonna make it more bigger, more appealing, but right now, I mean, it works right now. But the aesthetics comes later. But I can also toggle in here, and it will also like turn on. Okay. Like, I'm gonna turn it off. One that we're doing, for instance, for Estonia, it's a different one. This does not have the capacity to connect to the real world but it has the same principle. But this is a different machine. So this is a different machine that is called a strapping machine, and we explain it as well like the other one. No, here in front. So we explain it like the other one, like everything is. We're guiding the student to go from A until Z, so they know exactly what happens with the machine. In here, it has more modules, like for instance, the strapping machine. What is the strapping machine? And then it's like, let's take a look to the machine. If you go back and you see, you're gonna see that it has different sensors. It has different, I don't know. You'll see animations of how this works, you know. So, and then the objective is that they understand that this is a machine that is meant to strap around packages, pallets, and whatever, so they don't fall down. Okay. So we begin like a rough with animations, so they understand what is it about. And then we actually, well, here we have a control panel because they're more focused into what's. This is this is focused for mechatronics. So for instance, here we can open the control panel. Oh, okay. And then we'll see. Oh yes, this is what I'm telling you. So you need to measure in here a tension of about 24, and you go with the point. Okay. And this is how. But everything is guided. The objective is that everything is guided. In here is not really the problem. The problem in Estonia is that the professors that from the school, they are about to retire, and they're like 75 or something years old, and they want to keep teaching, but they don't have the time, neither the will to be there all the time in the school. So we are building systems so that they can learn more dynamically the students, and then the professor is still there, so he can actually answer the question, but it's not all the time with the students trying to teach everything from A to Z. So for instance, in here, we also say, what is the strapping machine for? We have animations about, so the first part of the strapping machine is the conveyor. So do you see this conveyor belt? Oh, this is the conveyor, and then we make it very, very simple to understand. And we also have this images always accompanying the animations. And for instance, here we have like this arrow in here that makes it very obvious, to understand what is exactly the conveyor. So we explain all the parts of the conveyor, and then we explain how to automate the conveyors. Like first you have to automate the motor, and then you have sensors, and then you have actuators that are going up and down, and then there's like a pneumatic machine. So everything is like well explained. And once you end with the whole entire operation, then you learn to troubleshoot the system. So we work with a Spanish company who taught us how they manufacture this, and they told us, the most common problems here is that normally the pressure does not go down, because sometimes there is fault in the pressure for the pneumatic system, so it does not go down. And then normally what happens is that there's a clog in the system. These systems are with pressure with oil, and they say sometimes the oil just gets dirty and then just clogs. And then there's any more chance of. So we simulate this in here, and then students, they see, oh, I'm gonna try to find the error, and then they go and measure. Okay, it's not electrical the problem. Oh, I'm gonna go and see here. Oh, this is not anymore the problem. And then until they go around. Oh, the problem was here. So now they understand.